some students asked whether I can share some data visualization topics because that's something I mentioned in the first class, in the first week. So I brought some topics about data visualization here. So personally, I'm really big fan of this kind of data visualization, and I think it's quite important to visualize data in a nice way so that you can communicate with your reader and audience in a much better way, especially when you have to explain something out of your data. And this topic, the storytelling through data visualization, I actually have been sharing and presenting this kind of topic in many different places in the public with the public audience. So sometimes I was invited by some company to present this topic, and sometimes in an organization and also in a university when we have like a public lecture. So sometimes I share this topic. So it's not really related to the big data directly, but I think it's a good topic, and I hope you can get something interesting idea out of my talk today. So I talk about storytelling through the data visualization, and before that, I want to briefly mention what I'm teaching in the university. So this course, which is selected topics in the it's the selected topics in the business and big data management. So this is one course that I'm teaching newly for the MBA program in this semester. And other than that, I have been teaching these courses for the undergraduate program and also master's program in business analytics and information technology management. And the course I'm teaching for undergraduate is business information systems. So here I cover many different tools and techniques which is related to the information systems, something like business analytics. So some of the ways of analyzing data, and also information technology, what kind of technological tools are out there so we can utilize, and also some of the data science concept, so which is related to the data analysis and data visualization and data communication. So those things are some of the things I teach for the undergraduate program. And for the master program in our university, we have a Master of Science in Business Analytics and also in Information Technology Management. So there I have been teaching database and big data management. So that course is more technical than the course that I teach here for the MBA program. There are a lot of overlaps, but I focus on more technical and actual usage and actual operations of the system. So there I focus on database, relational database like MySQL, and also NoSQL like MongoDB. So similar to here. So I focus on those two things. And when you see like what I teach here in the university, basically everything I teach is related to data. So it's all about how to deal with the data. And this is a kind of a trend in many of the business school and also non-business school too, in many of the programs in the university and also from the industry and from the practice. There has been a lot of demand in kind of knowledge and skills about how to deal with the data. So that's kind of things what's happening out there, and I'm sure that everyone here is also familiar with this kind of a trend. So we have this area called data science because of importance of the data, and you can see many of this kind of picture or this kind of like a snapshot showing what kind of knowledge and what kind of skills are required for data scientists. So if you really want to be master of a data science area, what should you like study? Something like that. So many people say that you have to study math, statistics, programming, and something like database because it's where the data will be stored, and domain knowledge. So where you are going to apply data, then you have to know something about that area. So that's what domain knowledge is there. So math and statistics, I think there has been already like an importance there. So people already know that, and they already want to study this kind of area. So there are a lot of courses, a lot of programs offering statistical method knowledge. And similar to programming and database system, a lot of people talking about it, and anyone knows that programming and database knowledge is very important. So this kind of a computational tool or this kind of information technology tools and softwares, many people are trying to run it. So they took a course in the university. So sometimes they run it by themselves by looking at the materials online like this. And domain knowledge and soft skills, those are also important if you want to apply these skills in certain area. And the last part is communication and visualization. So I think this is the part where many people may not focus that much actually, because if you just look at like course catalog, or if you like look at what kind of courses you have taken before when you are in the university back then there were not many courses focusing on communication and visualization. Most of the course, majority of the courses and majority of the people are talking that the analytical skills, computational skills, those are very important, but not many people talk about communication and visualization. So basically, in our program and in many of the like industry and many of the practice, we heard a lot of times we heard that how to analyze your data from various angles. So this is very important, but we don't talk much about how to actually visualize data. So the question is this: why this part is important? Why data visualization is important? So I want to talk a little bit about that. So first of all, we have too much information. So sometimes we suffer from information overload when we are presented with too many information. So information overload is basically a difficulty a person can have understanding an issue and making decisions that can be caused by presence of too much information. So of course you have some raw data like this, some log data, and you analyze this data. So you have some statistical results. And you can also have more nice tables, which is summarize multiple analysis you have done through many statistical software and many economic tools like this. However, presenting these tables and raw data to the user and to the audience will not be really effective. I mean, you will know that if you just present raw data and the tables of the results of statistical software, then this, of course, those are important things. You have to do it to analyze data. However, the audience will not be able to understand your point. Like there are too many informations, they have to go through one by one. It will take too much time, and also it's difficult to grab what you are actually trying to emphasize here. So these days, too much information, like presenting too many information around us is just like this. So I'm not sure whether you have played this game before. Like when I was young, I think I had like a cartoon book which is full of this game. It's called Where is Waldo? So basically, in this picture in this like a cartoon with a lot of people, you have to find this Waldo. So this guy is somewhere in this screen. So can you find him? I'm not sure. So there are too many people here. There are too many information. So finding something important here, basically finding this guy here is very difficult. So I'm not sure whether you can find it. So in my case, I already found that guy before this class, and he is actually standing right here. So it's like this. So when you have too many information, finding something really important and presenting something really important is very difficult. So that's why we need a data visualization. So data visualization is basically a technique you can use to communicate data or information by encoding it as a visual object, so you can have a better communication with your audience. So instead of presenting raw data, you can make some chart, some graph, or some like utilizing more advanced chart like this. So if you provide this kind of visual object to the audience, this can be actually a very quick solution for the information overload, because by looking at this, you will know exactly what's going on. So just by looking at this, you know that Germany has, it's France, right? France has very, is it Germany or France? Oh, it's France. Has a very darker color. So something is much higher there, some value is much higher. And you can see upside trend and decreasing trend, something like that. So presenting information through the visual object is very efficient. And there is also scientific support. why visualization is a more effective way of communication. So this guy, this slide that I'm showing to you is actually captured from bandwidth of our sense by Danish physicist Nord Tor Noretenders. So he tried to present how fast we are able to handle information from our sense. So basically, as a human being, we have a multiple sense. So people say that we have like 5 different sense, something like touching and hearing, smelling, listening, and looking, like this. So we have our eye, ear, and mouth, nose, and we are able to gather information around us. And depending on what kind of a sense we use, the amount of information we are able to getting is all different. So first of all, we have our tongue, and using our tongue, we can taste something. And by tasting something, we are actually getting some information to our brain. So by tasting something, we are able to get information as fast as a regular calculator. So we get some information, but it's smaller and not as fast. And another sense we have is ear and nose, so we can hear or smell. So it says that by hearing or smelling, as a human, we are able to capture about 12 megabytes of data every second. So smelling and hearing, by doing that, we are able to handle information as fast as our hard disk drive on the computer. Another sense we have is touch. So we have our hand and we touch something and we feel something. So by touching, we are able to processing about 125 megabytes of information per second. So this is as fast as a USB thumbstick. The last sense we have is our eye. So using our eye, we are able to see something and we are processing information. So by doing that, we are able to handling about 1,250 megabytes of information every second. So it's a lot of information compared to other sense. And this is as fast as regular network bandwidth, basically. So the thing is this, so we are capturing all this information from different senses in our body. However, it says that only 0.7% of all these informations are consciously processed by our brain. So what we are aware of and consciously understanding will be only 0.7% of all this information. So what's happening is this. So most of the information, 99.3% of information, will be processed unconsciously. So that's what this is telling. And that's why the vision, like visualization, is very important, because most of the information we are getting through is from our eye. So we are looking at something, we are getting most of the information, and all these informations are going to be processed unconsciously, even though you actually recognize or acknowledge. So it's a kind of process we are going through as a human. So visualization is very important. So the thing is this, when I present just something, you will just see and you will just unconsciously know that what is good and what is bad. So probably you heard about this, like when you meet someone for the first time, the first look is very important, because we are going to unconsciously have some idea about that person by just looking at them. So it's a similar thing. So even in the data visualization, the same thing happens. Depending on what we present, people will see your visualization and they will have an idea whether this is an effective visualization or bad visualization, like this. So let's think about this. I presented 2 graphs here. So one is on the left. So the left graph is a 3D pie chart. It uses fancy font. It uses a lot of different color and the shade and a lot of things. And one other graph on the right side, I use the 2D bar chart. So it's very simple. I use a standard font. I only use a few colors and it's designed quite in a simple way. So both of this chart actually show the same information. It shows a market valuation of different hotels in the different companies in the hotel industry. So when you see these 2 chart, one on the left, one on the right. Do you think which one is a better visualization just by looking at this? Can you type what you think on the Zoom chat box? Like, do you think the one on the left is better or the one on the right is better? So what do you think? Okay, so when you type here, and many say the right one, right? So some people may say left one, that's also okay. But many people say right one here. So actually, from my perspective, I also agree that the right one looks better because it shows the information that I want to see more obviously. And just by looking at this, I can kind of guess what the presenter is trying to talk to me. So yeah, exactly. So Carol mentioned that it can catch eyeball more easily, and that's also another thing. So I'll tell you why this is happening through today's talk. So the question is this: when we are able to recognize what is good and what is so bad, then why people are making bad visualization so many times? I mean, if you just look at the industry, you can just look at the news, or you can just look at the news article on the online, and you can just look at the presentation made by other people. And all the times you are able to identify there are bad visualization. There are some of the reasons. So one of the reasons is the absence of natural skills and lack of training. So natural skills, so nobody is born with naturally good at visualization. I mean, maybe some people are more better in some sense if they are more artistic or something like that. But there is no natural skills about the visualization. And the most importantly, there is a lack of training. So this goes back to what I talked about earlier. In many of like different area in the university and in the school and in a company, we focus on how to analyze data, but we do not have much focus on how to present data. So that's one of the problems. So when you think about when was the last time you get training in data visualization, probably, I'm not sure, you are really into this area, probably you did it, but if you are not into this area, you probably didn't really care much about it too. So there's a lack of training. And another reason is this. Often we rely on our tools to create visualization. So we think that visualization is an easy thing. We already think that analyzing data is difficult. I mean, of course, analyzing data is difficult. That's true. But we also think that visualization, creating graph, creating chart is easy because if you go to the Microsoft Excel, there's a button. If you click button, the chart and graph is automatically made. So we think it's an easy process. That's another problem. So we just rely on tool defaults and we leave our data and we leave our story not embedded inside our visualization. So that's another problem. So lack of training and just relying on tool defaults without thinking too much, then that basically results into the bad visualization. So that's why we also see many bad visualization in these days. So for the data visualization, there could be two big topics again here. So one is a fundamental concepts, another will be technical skills. So here in today's talk, because of the time limit, I focus on the fundamental concepts. So I talk about some of the common mistakes in visualization what people are making. So people sometimes make a misleading graph and statistics. And I'm going to show you some examples of bad visualization, which I captured from the real world. And I talk about some of the visualization guideline, which is designed to make a good visualization. And I included some exercise here, so you can try. And also I'll talk about visualization with the storytelling and big data a little bit later. So I focus on the fundamental concepts on today's talk, basically. So the common mistakes many people are doing is making a misleading graph. So if you make some mistake, when you do visualization, you will make a misleading graph. And this is a graph that misrepresents data. And sometimes it can have some misuse of statistics. And if the audience sees this kind of a misleading graph, they are able to infer an incorrect conclusion. So you should be very careful of avoiding making misleading graph. So misleading graph is something like this. You look at this nice hamburger, but actually when you go there, they serve this. So it distorts your data in some way to present it in a different way. So here are some of the misleading graphs many people are making. So let's look at this. So I have this chart here. What is the biggest company in the hotel industry? And based on the market valuation of each company in the hotel industry in 2016, I put that in this 3D pie chart. So anyone, can you guess what is the problem here? So it looks like if it's fine, right? It shows the data. This 3D pie chart is made in Microsoft Excel by using market valuation data of these 1, 2, 3, 4, 5, 6, 7, 8, 7 companies basically. So I just used the Microsoft Excel to create this 3D pie chart. Can you guess what is the problem here? Anyone would be able to find out the problem? The problem, let me tell you, the problem. So some mentioned no percentage marked, no numbers. I mean, that's fine. Let's think that we just excluded the numbers. But actually the problem is this. If I make this chart using the 2-dimensional graph, then it will be like this. Let's think about this. When you look at this 3D pie chart, which hotel has the biggest market share? It looks like this one, right? Marriott or Hilton. So when I just presented this 3D pie chart, and if I ask people, can you identify which hotel has the highest market share, then people will mostly say Hilton or Marriott. They will never say Airbnb because Airbnb looks small in this 3D pie chart. But when I convert this into the 2D pie chart and I put the actual number here, then now you will see that actually Airbnb has the highest market valuation. And also in this 2D pie chart, Airbnb looks the biggest compared to the Marriott like this, right? If you compare size of Airbnb and size of Marriott, it's more obvious. In this 3D pie chart, Marriott looks much bigger, but actual number, Airbnb should be much bigger. And when you visualize this information in a graph format, Airbnb should appear bigger because it has a higher market valuation. So that's the mistake of using 3D chart. So if you use a 3D chart, basically it distorts information because when you make a 3D chart, there is something called the perspective. So some of the data which will be shown behind much further will look smaller because of how the 3D chart is being made. So that's one of the mistakes that I see many times in the graph when other people are making. Another example is this. So this is another mistake of using 3D chart. So when in this case, they made 3 bars using the 3D bar chart basically. And the blue bar and green bar actually have the same value. It should be exactly the same. But when you just look at the size of the visual object, the blue one looks much bigger. And it can give a wrong impression to the audience. When audience see this graph, they will think that the blue bar is much bigger because the size here in this graph looks bigger. So use of the 3D chart may confuse the readers because of the mismatch between size of visual object and the actual data. So that's one of the mistakes we have to avoid when we make the visualization. So it is strongly discouraged to use a 3D chart unless it has to be used to provide the unique information. So that's one thing I want to mention here. And also this is another problem. So let's say that we made this 3D bar chart like this. Then which one is correct? Should we look at the blue line or red line? Which is the correct value of this bar chart? We will never know, right? So that's another problem. In Microsoft Excel, according to the Microsoft Excel, so I tested it, and according to Microsoft Excel, you have to look at the red line. So which is not really intuitive in this case. So another misleading graph example is this. So in this case, I used slightly different things. So sometimes when we visualize information, we use kind of a picture or logo, and we change the size of a picture and logo to present the information. So in this case, I used, again, market valuation in the hotel industry, and I took 4 companies from there. So SPG, Starwood Group, Marriott, Hilton, Airbnb. And based on their market valuation, I changed the size of their logo, and I show that this shows market valuation of the top 4 companies in 2016 in the hotel industry. So when you look at this, it shows the information correctly, right? You will know which is the biggest company in hotel industry. Of course, it's Airbnb. But can you guess what is the problem here? Can you notice some problem here? Is there anyone who can notice what's the problem here? So I can show this in the next screen. So basically it's the same thing. There is a mismatch between the number, the actual data, and the size of the visual object. So it's like this. When you look at Starwood Group and Airbnb, it's more obvious. So between these 2 companies, Airbnb, the market valuation is about twice bigger than Starwood. So Airbnb's market valuation is about twice of Starwood. However, if you look at the size of their logo, then it looks like Airbnb is about 4 times bigger than Starwood. So that's the problem. So actually Airbnb is the biggest company, that's true, but it's not as big as that. It's just twice of Starwood Group's size. And in this visualization, I'm distorting that information. I'm making it look like Airbnb is a much bigger company than it is. So we call this as improper scaling in visualization. So when you do scaling, you made a mistake. So it's improper scaling. And sometimes this usually happens when we use a pictogram. So pictogram is a chart or graph which uses a picture to represent data, like what I did earlier using the logo. And pictograms in bar graph should not be scaled uniformly, because if you scale it uniformly in both width and height, then when you scale twice, actually the size becomes 4 times bigger. So that's the problem. So it's basically this issue between A and B. So B is 3 times bigger actually, but you make it look like B is 9 times bigger because you scale it uniformly. So you should be careful. So when you use a pictogram, you have to use and scale in only in one direction, so that you can represent the data in a more correct way. So that's another many people make mistakes, and this is called as improper scaling. So another thing is this. So this time I used the Microsoft Excel, and I put the market valuation of each company, and I made this bar chart. And I can ask what is the biggest company in the hotel industry, the same question. And the problem, so because of the time, so I go a little bit faster. So the problem here again is this. In this case, when I make the bar graph, I use the truncated graph. The truncated graph, by definition, it is a graph where a bar, where the axis does not start at 0. So if you look at the starting value of the axis, it starts at 6.5. And if you use some software like Microsoft Excel, they actually do this automatically, which I really don't like because it distorts data. The problem is this. Also, there is a mismatch between the actual size of the data and the size of the visual object here. So if you compare Airbnb and Accor Group, then Airbnb is actually about 2.5 times bigger than Accor Group. But if you look at this graph, it looks like Airbnb is about 5 times bigger than Accor. So there's another misleading information here. So by using a truncated graph, it's possible you may exaggerate a little change into an important change. So you have to be careful about that. So commercial software like Microsoft Excel, they tend to truncate graph by default like this. So if you see many of the graph online, or in the presentation, if they use Microsoft Excel, you can see that the graphs are mostly truncated. However, so this happens because it's Microsoft Excel. So Microsoft Excel is developed a long time ago. When Microsoft Excel came out, people didn't think much about visualization. But now if you use a visualization tool like Tableau or Microsoft Power BI, those tools which are specialized for nice visualization, they do not do this. They don't truncate your graph by default. So that's what I noticed. So that's just something you have to be careful when you're utilizing some older tools and make a graph like this. Another misleading graph you may make is by doing axis change. So let's just say that this is the original graph. So from 1990 to 1994, there is a steady increase of the value from 2 to 10 like this. However, you don't like this. Let's just say that this is something like unemployment rate or inflation rate. Then government may have some agenda to make it look like there is no issue. Then what they can do is that they may increase the y-axis really huge and then make this slope much flatter. So sometimes I see this kind of graph in the reality and people are actually using it. So this is another things we have to be careful when we are making a graph. So changing the y-axis maximum or changing the ratio of graph can affect how the graph appears. And also it's possible, let's say that this is kind of economic growth of the country or sales increase of the company. They want to show that they are actually having really rapid increase, then they can change the ratio like this. So they make this x-axis much smaller, then it looks like we are having much rapid increase in our data. So sometimes I see that this kind of manipulation in the real world, and this kind of manipulation can trick the audience actually. And the audience may think that there is not much change or there is a rapid change over time, depending on how you present your visualization. So as a person who are using a lot of data, we should be really careful about this kind of mistakes. Another thing is omitting data. Sometimes we omit some data to present our data more nicely. So let's say that this is some of the information. So let's say that this is our sales from 2000 to 2010 over the years of a company. Then company's sales are overall increasing, right? It increase and decrease, increase again, decrease again, increase again, decrease again like this. So there are some pattern like this, but is it possible you want to show more attractive pattern to your customer or to your audience, then you may decide to remove some of the data. So for example, in this example, you may decide to remove the data from the odd year and only report data from the even years. Then it looks like there's not much going up and going down. It only goes up most of the times. So you can show much better pattern to the people. So this is another another kind of misleading graph sometimes I see. So if you omit some important information or if you hide it, the wrong conclusion can be inferred by the audience. So that's something you have to be careful. And sometimes where I see this, and sometimes in the financial reports, they want to exclude the negative returns and they want to create more favorable visual impression on purpose. Then sometimes it looks like they do that. But in like official document, of course, they shouldn't do it because it can have some legal consequence. But like in unofficial times, in unofficial document, sometimes I think they do that. So this is something you have to be also careful about it. When you visualize your data, you want to make sure that you don't hide any negative or unfavorable results. So similar to the omitting data, another problem, another mistake many people are making is this: improper extraction or improper sampling. So let's just say that this is the company's sales over time, and usually it's around this level, but at a certain time it went really high like this. So you want to emphasize this. You want to really show this and say that your companies are doing really well. then you can extract only those parts. That's also possible. So usually we use extraction when we are searching for a certain anomaly in our data. We want to look at those periods more carefully, what's going on, to analyze it. But sometimes they do it improperly, and then they want to give, if you do that, then it will give a wrong impression to the audience. So that's another mistakes many people are making when they are visualizing their data. So this is another thing. This was the quality is not good, but this was a huge commercial the Colgate company did in many different countries, in the US, also in UK, and also in China. They commercialized by saying that the Colgate was recommended by more than 80% of dentists. It sounds amazing, right? More than 80% of dentists recommend Colgate. Then it looks like Colgate is a superior brand in the toothpaste industry. Can you guess what is the issue here? So there was a huge issue in this commercial. Exactly. So yeah, so it's exactly, yeah, the answer. It was not exclusive. So what happened was this. The survey they did to the dentist was actually multiple choice survey. So they asked, what do you recommend to use? Something like that. And then 80% of dentists, of course, check the Colgate toothpaste because Colgate toothpaste is there, but they also check the other toothpaste. But basically, these 80% of dentists, what they did is that they asked people to use toothpaste. That's it. They were not saying you have to use a specific brand. They were saying you have to use a toothpaste. And Colgate used that to advertise that 80% of dentists recommended to use Colgate like this. So that was basically misreading statistics. So you do survey and you are interpreting statistical results in a way totally to favor like your agenda. So that was a huge mistake. And this commercial, because it was a commercial, it was affecting consumers in a wrong way. So it was banned and it was fined in many countries, including US, UK, and many European countries eventually. And for example, in China, Colgate was fined for $1 million US. So it was a huge mistake they made. So there are many of the mistakes people are making. And what I want to do is that I want to share some of the visualization made by other people in the real world. And these are really bad visualization. Sometimes it can be, and this bad visualization can be sometimes made by mistakes. So sometimes because earlier, as I said, we don't really go through the training of how to make a good visualization, and many people lack of training in this area. And also sometimes they just use the default tools. So it's possible they may make a wrong visualization by mistake. That's definitely possible because they may not understand the data and visualization process well. And sometimes when you see this visualization, some people make bad visualization intentionally. They want to make misleading visualization to distort and misrepresent the data, and they make it intentional to change others' perspective or to affect what other people think. So basically, those people who are making misleading visualization intentionally want to promote their agenda. They have something to tell, and they want to persuade other people of their agenda. So they just make misleading visualization. So that's why we have to understand this area. And we have to have a good understanding of the visualization process. And we should be able to accurately point out what is done wrong and what should be done correctly like this. So whatever the case it is, the bad data visualization is not good. It can derail the message we want to communicate, and it can lead the audience to the wrong and inaccurate conclusion. So this is really not a good thing we have to do in the reality. So I want to present some real-world examples of misreading graph, so you can actually take a look and you can see how it looks like. So if I didn't talk that this is a misleading graph, you will just look at this and you just think that cost of gas is increasing over time, right? So last year, it was 3.17 US dollar. Last week, it was 3.51 US dollar. And now it's 3.57 US dollar. So cost of gas is very expensive these days and it's increasing. So that will be probably something you will get if you don't really think about visualization. But now you heard about people can make a misleading visualization intentionally or by mistake. Then when you look at this visualization now, can you guess what is the problem here? Anyone can guess what is the mistake here and what is done wrongly when they made this visualization? Yeah, so actually it's all correct. So Rhoda mentioned the period of time, basically x-axis has a problem. And also the Severin Dennis mentioned that omitted data is a problem. Yeah, both are correct. So they omitted data and they also misrepresent the x-axis. So if you look at x-axis, the time between these two are 1 week. But here between these two, it's not 1 week, right? It's 1 year basically. So there is no consistency in terms of x-axis. And also another problem is this. This is 3.17. It says it's last year, but actually it's not shown on the graph, but actually this is the lowest gas price in the last year. So this is from the Fox News, and the Fox News found the lowest price of the gas in the last year, and they put it here, and they put the price of last week, and they put the price of the current week. So it's totally misleading data, and it's totally wrong information. So actually, yeah. So that's what they showed in the news, however. And people who doesn't understand the visualization, they see this and they will just believe exactly as what the graph says. So this is a huge mistake. And here, this is another screenshot I captured from Fox News channel again. So it says that after the Bush tax cuts expire, the top tax rate will increase from 35% to 39.6%. So basically, it's the top tax rate. So basically, the richest people in the US has to pay more tax. Can you guess what is the problem here? Anyone can guess the problem here? So this one, the problem is actually quite obvious, right? So the important problem here is actually this one. So actually this timing is it's now is right now, and in the US the tax rate changes after the new year, so it means next year. So the x-axis is fine, but the big problem here is this. It's the graph actually starts from 34. So they used truncated graph. So of course, I mean, after the Bush tax cut expires, the richest people in the US has to pay more tax. I mean, that's true. However, they are not going to pay this much tax. It looks like after tax cut expires, the rich people has to pay like 4 times more tax. Well, actually, that's not true. The increase should be like this. So if you make the graph starting from 0, then the actual difference just this amount. Of course, the richest people have to pay a little bit more tax, but it's only about 4.6% more. It's not like 4 times more. So that's totally wrong in this case. So that was the mistake here. Basically, yeah, as Carol mentioned, they exaggerated the change in this case by using truncated graph. This is another graph I captured from the same news channel, Fox News. It shows unemployment rate under President Obama. So it starts from January, it ends on November. So during the 1 year in 2011, Fox News wanted to show how the unemployment rate is changed under President Obama. So can you guess what is the problem here? So there's really, I mean, if you look at the graph carefully, there's a really funny problem here, actually. So for other graph, I can say that, like for the previous graph, for example, for truncated graph, I can say that maybe it could be by mistake. I mean, this one, it could be also by mistake, but it looks a little weird. Yeah, exactly. The Ijong mentioned that the last observation here, it says 8.6%, right? So 8.6% is the same as 9.0% here. And if you look at more carefully, 8.6%, also I think the location of the line is wrong. But if you look at more carefully, 8.6% is actually higher than 8.8%. So this is a completely wrong graph. So if you correct the graph, actually, it should look like this. So 8.6% is here. So it's the lowest in the 2011. So basically under President Obama, eventually we had the lowest unemployment rate. So that's the conclusion from this graph. But they don't want to say that. So they change it graph like this so that you can have a long impression and accurate conclusion from this graph. So that's another example. And here is another example from the Fox News again. Can you see these statistics? So it asked, it's basically a survey. They asked the people, did the scientists falsify research to support their own theory on global warming? So basically they are asking, do you think global warming is a fake because of the scientists or not, or something like that? So 59% said somewhat likely, 35% say very likely, 26% said not very likely. Yeah, exactly. So one student mentioned that it's actually more than 100%. If you sum up this value, 59 plus 35 plus 26, it becomes more than 100. So there's something going on. This is not a correct statistics. And the original statistics was this. So it's from actually the survey done by Media Matters. And they were done in 2009 or 12, I'm not exactly sure. But anyway, this was the exact survey result. 35% very likely. So they put it here. So that part was correct. And 24% said somewhat likely. But in this Fox News, they combined this with this together. So they made another category here and they put it here. 35 plus 24, 59% said somewhat likely. And then 26 said not very likely. They combined these two again and they put it here. So basically, they distort this survey result and present it in a way they want. So these are some of the examples that I captured from Fox News. And if you want to see more like bad visualization or misleading visualization example, you can just Google Fox News misleading visualization. Then you will be able to find a lot more screenshots of their news channel, which shows misleading visualization. And these are from the other channels. So this is some sports channel, and they show that this guy and showing that his performance is not as like last year. So previous year in 2012, his ball speed was 77 miles per hour, but now this year his ball speed dropped into 75 miles per hour. So again, it's the same issue. They used the truncated graph, right? It doesn't start from zero. So that's the issue. So of course his performance got lower, that's true, but it didn't get lower by like a half. So they exaggerated it a little bit. And another misreading graph that I captured was this. So they want you to show market valuation, or not market valuation, how many sales they make across the different franchise in the US. And McDonald's made the most sales given this figure. But the problem here is obvious. It's the improper scaling. They didn't scaling. They scaled uniformly. So if you compare Burger King and the McDonald's, the difference is about 5 times, but the McDonald's looks like much bigger, right? More than 8 times bigger, basically. So that's a problem. So this is a problem of improper scaling. And this one is a very interesting graph that I found. So it's from, I don't exactly remember where I got it. I think it's from some of the website which believes that global warming is not true. So they showed this graph and saying that the average annual global temperature in the world in Fahrenheit, and they are saying that it has not been changing since between 1880 and 2015. So between 1880 and 2015, the average annual global temperature did not change. So they present this graph as an example. And the data is correct. So data is actually from the correct data set. Can you guess what is the problem here? Anyone is able to tell? I mean, we all believe that, I mean, people these days all believe that global warming is true. I mean, it is true that the Earth is getting warmer, right? About the side effect of global warming, there are some like debates, but it is true that the Earth is getting warmer every year. Can you guess what is the problem here in this graph? So if you look at this carefully, this graph is actually very interesting. So it starts from, first of all, it starts from 0 and it ends about at 110. Yeah, the scale is very interesting, right? So usually when you think about like average annual temperature, I mean, you can use F and Celsius, like both of things, but when you use Fahrenheit, it doesn't go down like a 0. If we go down like a 0, then everyone there will be dead basically. So this is something impossible we can achieve. Also, 110 is very weird. It's also really high average temperature we can actually have in the Earth. So if we want to see how the value is changing over time, we have to look at more reasonable range. Like what's the reasonable range of the global average temperature? And we have to look at that. But it kind of exaggerated y-axis range, and it made it look like there is no change over time. The actual graph, the original graph and the correct graph should look like this. It starts from 56, it ends at 59. And if you look at this range, you can see that clearly around after 1970, until then it was kind of flatter. And after that, you can see that there is a clear pattern of increasing the increase of the global average temperature. So this is the correct graph. However, they exaggerated this range really huge so that it looks like there is no change. However, actually, there is a big change like this. So that's another misleading graph that I saw online last time. So I wanted to capture and share it with you here. So you can see a lot of this kind of like misrepresenting information on a graph in many different sources actually. So the question is this: how we can make them, how we can avoid those misreading information, and how can we actually make a good visualization? So here are some of the visualization guideline I put it. So the first of all, it's important to understand your data and the audience. So depending on what data you have to utilize different way of presenting it. And also depending, you have to understand your audience. And depending on the audience level, you have to make the visualization to satisfy and deliver what you want to say to them more effectively. And then you have to choose an appropriate display. There are many different charts and graphs you can utilize. You have to choose the one which really fits to explain what you want to say. Also, it's good to keep the graph simple and clean so that your audience doesn't get distracted by other non-important factors. And you have to draw attention with a clear purpose. So when you make a visualization, there should be a reason. There should be a purpose why you are making this visualization. Then you have to clearly demonstrate your purpose. You have to clearly explain what you want to tell from your visualization. So that's another important thing. The last part is the final part. Once you finish your visualization, it should carry a story. There should be a certain reason why you are making this visualization. There should be a certain story you want to tell from this visualization. So instead of writing an article, you can just create a visualization, and that should be enough to communicate with your audience. So these are 5 steps of visualization guideline. And I show you simple examples of how we can apply this in the practice when we are actually making visualization. So first of all, we have to think about data and audience. So what data we'll use, what to present, and who is the audience. So if my example is this, what is the biggest company in the hotel industry? So I want to talk about this with my audience. Then first of all, I get the data. So to define biggest company, which data should I use? There are many different data. I may use sales data, I may use revenue, but I'll choose a market valuation data. And also, there could be many different companies in the hotel industry. So you cannot present to everything. So you have to limit your data into a certain level. In this case, I'll say top 7 companies based on market valuation. And also, who is the audience? So you have to have understanding of what do they already know. Should we explain every detail, or how much detail should I explain and or include? And which information should we provide? So you have to also think about that based on your audience. Once you have data and audience fixed, the next step is choosing a graph or chart to use. There are many different graph and chart to utilize these days. So you have to think about what is the most appropriate for your visualization. And some of the chart many people are using are these things. There could be bar chart. Usually bar charts are good at compare certain values across different categories. So you want to present a certain value, you want to compare this. Then bar chart is good. There's also pie chart. This is good at compare market share or proportion across different categories, because when you add up this, it becomes 100%. And 100% is divided by different category. Then you can present pie chart. And line chart is usually really good and show change of value over time. So you can put the time series here. On the x-axis, you can put the time, and you want to show the trend. It's changing like this. If you want to show this kind of trend over time, usually line chart is perfect. And another chart is a scatter chart. This is usually good at showing correlation between 2 different fields. So in this case, there's X field, Y field. You want to see how their correlationship change over time, or how their correlationship is different across different category. Then scatter chart is a good choice. Also, there is something called the area chart. You want to show the rise and falls of multiple items over time. Then area chart is perfect because it can catch the audience's visual attention very easily and quickly. So you can say that the vinyl record was popular and it died, and cassette tape came out, died, and compact disc came out and now it's dead. And now people are using streaming service to listen to music. And there is also a connected dot chart. This is very useful when you want to emphasize a gap between 2 items. So in this case, they are emphasizing how many people are very satisfied and very important and something like this. Also, when you want to show the gap of a certain item between men and female, like a gender gap, also it's good. So whenever you want to show a gap between 2 items, then it's very good. Slope chart. You can compare changes between 2 periods. So there's a certain period and certain period. So something happened between them. And you want to show how they are changed after this event. Then slope chart is a very good method of visualization. Now, another chart is a map chart. Many people utilize this these days because map chart is able to contain geographical information. So in the US, they use it very frequently. So given each state, the characteristics are all different. So usually during the presidential election, they show this chart to show that which state supports which party in the US, something like that. So in this case, when I talk about what is the biggest company in the hotel industry, I can use a pie chart or pictogram or the bar chart. but the best and most appropriate display, I think, is probably the bar chart. So pie chart actually is not good because we are not showing market share. We are going to show actual market valuation. So if we just want to compare a certain value across different category, then bar chart is the simple and it shows all the necessary information there. So we can decide to use a bar chart in this case. So once you define which chart type you are going to use, the next step is making it simple and clean. So you present all this information here with a different color, but it may not be that necessary. So we make it more simple. So we use all the same color like this. So we remove those kind of nice feature, like if you made the graph into 3D graph, make it into 2D. There's no reason to use 3D. And also if you use multiple color or a lot of colors, so that's too many things going on, then you make it as a simple color like this. So in this case, I remove all the design factor. So I make just this simple graph here. So I keep it simple and clean. And the next one I want to do is that presenting the purpose of this graph. So when I show this graph, what is the biggest company in the hotel industry? There's one company which is not in the traditional hotel industry. That is Airbnb. Airbnb, when you think about Airbnb, you will think it's more like an IT company actually. You will not think it as a hotel company. But Airbnb has the highest market share, highest market valuation in the hotel industry. So that's something surprising. And you want to emphasize that, then you can do it like this. Airbnb has the highest market valuation in the hotel industry. So I want to emphasize that. And I also colored Marriott and Starwood here with the same color, blue, because in this graph is made in 2016. And in 2016, something happened. What happened is that Marriott purchased Starwood Group. So they became one company, Marriott Starwood Group. So when we combine these two numbers together, now the traditional hotel company will take back as the first position in the hotel industry. So I want to emphasize that. So that's my purpose of making this visualization. Then now I made this graph and now I'm able to embed a story. So my story here is this. When I presented this graph, I presented this graph like this and I will tell this. So people can ask what is the biggest company in the hotel industry? And as you see here, Airbnb has been the biggest company in the hotel industry for the past few years. So it has the biggest market valuation in the industry, even though it's not a traditional hotel company. And many hotel companies at the time felt a threat by this kind of a new and trendy IT company. And one of the things many hotels did at that time was trying to reduce the cost. So if they reduce the operating cost inside the company, they can have a higher market valuation, they can increase the sales. So one of the big moves that happened in 2016 in the hotel industry is the Marriott and Starwood merger. So they merged together to become the biggest hotel company in the world. And that's what happened now. So many people now talk about this as more of an anti-Airbnb defensive measure. That's why Marriott bought Starwood company to remain as the top company in the hotel industry. And also, this shows that hotels want to bulk up against the threats from internet service like Airbnb. And this merger eventually gave its scale to take advantage of that to the Marriott company. So now Marriott Hotel is the biggest hotel company in the industry after this merger. So we can have this story. Just by presenting this graph, we are able to make audience to look at this because it's outstanding there. And then the audience will next look at this and they will try to think what's going on here. And then I will have a story to tell to the audience. So this is basically the way, one of the kind of simple way to embed a story into your visualization. So whenever you create visualization, you will put a lot of effort. Like one visualization, you will put a lot of effort to make it, and there is a certain region and certain purpose of why you are making that visualization. And then you want to have a story embedded there so that it can be self-explanatory and people will be also able to understand what you want to talk by presenting this visualization. So that's the visualization guideline here. And I put some visualization exercise here, and I think you can probably think of this. So I captured some of the visualization that I saw in the real world, and I was really frustrated. And I also want you to think about it. So let's just say that. So this is the slide that I received when I joined this university. So I joined this university to be a professor in 2016. And during the orientation, they were telling how good CHK Business School is. And of course, I agree. CHK Business School is very good. And also the ranking, MBA ranking is very high in terms of Financial Times ranking here. But the way they present the visualization was so bad. So I just want to show this here. So they say the MBA ranking in the FT has been always like increasing like here. And there are some missing value, but it's okay. They say that it's the highest in 2016, and the EMBA ranking has dropped a little, but still it's in a higher position, in a good position like this. So can you guess what are the problems? And if you want to improve, how you can improve this visualization? Like if you have any idea, any thoughts, can you just write down something on the Zoom chat box? Can you guess like what is the problem here in this graph? I mean, this graph looks so bad, right? When you see it, you will notice that it's not a good visualization actually. Anyone can guess? Counterintuitive, right? Yeah, that's what I actually exactly felt when I look at this, and it's just not me, I think. Everyone who look at this graph, they will feel a little uncomfortable because it's very not intuitive. One thing is that here number is 26, but it has the highest bar, and it has a 30, it has the lowest bar. So I understand that why they made it like this. They want to put lowest number to the highest point, right? Because for the ranking, if it's the lower number, it's better. But this number doesn't match with the size of the visual object. So that is the problem here. So what should we do? Actually, in this case, if we use a line graph, it will be much better. So if we just use a line graph, then I can put MBA ranking like this. 28, 27 here, 30, 26 here. So MBA ranking has been always steadily in a good position. So for the missing variable, we can just put it missing like this. And the EMBA ranking also, we can just put it here like this, and we can make a line graph. Then it can show the trend over time. And also in this line graph, we can put 1 on the top and the low or higher value on the bottom. Then there is no mismatch between visual object you see and the number you see here. So lower number will become the highest. And we are not using the bar chart, we are using the line chart. So there is no size of bar which will not be matched with the ranking in this case. So actually, in this case, actually they have to use a line graph. Then all the problem can be solved. And this is another line graph that shows you ranking of Australian business school. And I took this graph from The Economist. So actually, Economist is a good magazine to look at, and you'll be able to kind of see many of the good example of visualization. So yeah, you can solve it like this. So actually, we are over time, so I have put more visualization exercise here. I think you can do it by yourself. You can think it by yourself, and I actually put the solution on the next slide here. So I share this later on the Blackboard, so you can see the problematic visualization, and you can also see how I can resolve that kind of a problem by presenting different style of graph. So you can have a better understanding by look at this. So this is another graph I captured from SCMP. This one is really funny. They say that this was, I think, after the protest. So in 2019, there were a lot of like protest in the Hong Kong, and they are saying that Hong Kong was losing Chinese tourists from the mainland because of the protest, and instead Singapore is getting more tourists because so basically they are saying that the Chinese mainland people are traveling to Singapore instead of Hong Kong. That's what the news article was saying. It could be true in some sense, but it's actually not really true because the measures are different. For Hong Kong, they use million, and for Singapore, they are using thousand. There is a huge difference in that. So the actual graph should look like this. So Singapore, it increased a little bit, but not that much actually. Hong Kong, it decreased a bit, but still, compared to Singapore, most of the mainland tourists are still coming to the Hong Kong. So that should be the conclusion actually. But they changed the axis, the y-axis for each, for Hong Kong and Singapore differently, and they kind of overlapped here, and they made it look like Hong Kong is losing against Singapore like this. So that's another, and in the statistics, we call this as a spurious correlation. So you find something correlated and you put it in a similar way in a graph, you make it look like it's actually happening. Something like this. This is another example. They put it like this. But however, if you look at closely, the y-axis value is different. So the actual graph should look like this. So in many of the news articles, sometimes I see this kind of a misreading graph. And this is another thing. So you can check it by yourself. So I skip this because of the time. And the other things I want to mention here is this kind of things like when we have the big data, it's difficult to put everything in one like a traditional graph or chart. So you have to be more creative. So you can check the slide for more details. So I skip here. And something like this. I think this is a really creative visualization. I took this from the, I don't remember where, from this website here. So you can check it later. What I think is really creative is this. When you present the GDP information of the different country, usually they use this table, very long table with almost 300 entry, or they use this bar chart, which never ends, almost 300 bars, or they just use this geographical map. Then I have to look at this color, and I have to look at the number here, and I have to compare like this. So it's very difficult to fully understand what's going on. But in the in this website, which is a view of the world, they kind of change the size of each country based on the GDP level of those countries. So if the GDP level is high, the country shows much bigger. If the GDP level is low, the country appears much smaller. I think this is a very smart visualization because by just looking at this, I can compare GDP size of a different company very easily. Like the US has a very huge, it means the US has the highest GDP in the world, and Canada is quite small compared to their actual size. And European countries are so fat, so European countries have a much bigger GDP than their actual size. The Africa are almost gone, so African countries have a very low GDP level. In Asia, China is the biggest here. So basically, China has the highest GDP in Asia and second highest in the world. And India is quite big. And so in the East Asia, you can see Japan and South Korea is quite big. And you can see that North Korea is gone, basically. So you can compare different information much easily by just looking at this chart, this graph. So I think that's quite interesting. So, I mean, there are more things I want to talk about here, but let me just skip because of the time limit and some other interesting graph. So the thing is this, like this one, if I talk briefly, I think probably you have saw this in somewhere. So this is a very popular graph in the visualization. What they did is that they captured this data from the Facebook and they look at when your relationship status change, when your relationship status change from single to in relationship or from in relationship to single. They checked that and they made a graph like this. So they found when people usually break up by looking at this data. So usually people break up a lot during the spring break because during the spring break in the US, it's like a vacation. So they go travel to somewhere like Mexico and they found another guy and they eventually break up. Something like that happened. And also April Fool's Day, people break up a lot. So you may make a joke. Let's just say that, oh, let's break up. And you made a joke. And actually that ends up with reality, something like that. And also very interesting, people usually break up a lot on Monday. Maybe something happened during the weekend. During the weekend, they hang out together and they got into argument and they break up on Monday, something like that. Summer holiday, they break up a lot. And it's funny, 2 weeks before winter holiday, you break up. Maybe 2 weeks before Christmas, you find out that actually you don't want to be with that person anymore. So you break up, you realize that, something like that. And during the Christmas, you will see that it's the lowest. So Christmas, you never break up because I don't know, it'll be too lonely if you break up during the Christmas, something like that. So what I want to show you is that if this kind of pattern like it doesn't exist in like a statistical software like this. So if you want to find something unique, then you have to first visualize data to see this kind of a unique pattern. So that's another reason why visualization is quite important. So more information here, but I skipped this because of the time limit. I'm already over time, so I don't want to go over too much.